In Chapter 45, we continue our ecosystem discussion with learning about biomes, which are large regions with a very specific set of weather pattern. And then also, we learn a little bit about global weather and general trends that affect weather in these biomes. You'll notice in section 2 where we talk about the major biomes, we are only covering a couple of them. You are only responsible for the ones that we cover in class. So we're going to start off talking about climate patterns and global weather patterns. So climate is essentially the prevailing weather pattern in a region. So if you think about somewhere that you really like to vacation and think about the general weather there, that is the climate. The day-to-day weather forecast is affected by the climate. So if we think about the Midwest, you probably think hot and humid summers with some thunderstorms, cold, drier winters, but we do get some snow precipitation. So those are the big climate patterns, but then our day-to-day forecast might vary. So we might have cold days in the summer, we might have warmer winters, things like that. But the climate is that big prevailing pattern. So that pattern is going to be affected by two main things: the temperature in the area. So this is going to be the average temperature and trends for temperature in a particular area. And then also the precipitation. So you might think of places that are generally much colder. So the Arctic regions are much colder, whereas the tropical regions are much warmer. You might think of places that are hot and dry, like the desert Southwest. You might think of places that are hot and wet, like our tropical areas. So all of those are examples of climate and the types of temperature and precipitation ranges that you might see. So climate is going to determine the different biomes around the planet. So bio always means life. So these are major community types. So we are going to be looking at the flora or the plant life and the fauna or the animal life that are common in these major areas. And the temperature and precipitation are going to have a direct impact on the type of organisms that live there. So overall temperature patterns are going to vary based on the latitude of the Earth. Now, latitude means how far north or south a place is from the equator. So we are going to talk about what happens at different latitudes, and anything that we talk about trend in the northern hemisphere is going to be mirrored in the southern hemisphere. So because we're in the United States, we're going to focus on northern hemisphere, but just keep in mind that all of the mirrored patterns happen in the southern hemisphere as well. So temperature is going to be a direct effect of the solar radiation that hits our Earth. More intense sunlight means warmer temperatures. So this is why our tropical regions are much more warm than our polar regions, because they get more direct sunlight, and they get direct sunlight all year round. So let's start at the equator. I know that's backwards from the slides, but let's start at the equator. So right in the middle of our planet, near the equator, sunlight is going to be more direct, and it is going to be direct and concentrated all year round. So regardless of the season, there's going to be direct, intense sunlight all year round. And so the Earth's rays are hitting our equatorial regions directly. Now, as we move farther north around our globe, the Earth's rays are still hitting, only some of them are diagrammed, but as we move farther north, the sunlight is essentially hitting at a flatter angle. And so what happens is you do get some sunlight reflected off from that angle, but the sunlight that does hit is spreading over a wider surface area. So At the equator, we have this small surface area of direct sunlight. And as we move farther, we see this sort of spread out area of sunlight. So we are still getting the same sunshine hitting both regions, but it's hitting it in a different way. And so the sunlight is going to be less intense. The heat in the sun is going to be less intense. We would call this our solar radiation. And so when the solar radiation is more direct, it's going to lead to higher temperatures in that area. When the solar radiation is less direct, we're going to have less intense solar radiation in those regions and therefore lower temperatures. So this is why as we move towards either the North or the South Pole, our temperatures decrease. There's a second reason as well that we'll talk about in just a little bit. This graph on the bottom shows annual temperature and latitude. So as we move farther north or south from the equator, our average temperature is going to decrease. So up between latitudes 0, which is the equator, and 20 degrees north and south, we're going to have roughly the same hot temperatures between 25 and 30 degrees Celsius, which is going to be mid 70s to low 80s average temperature. And then the farther we go, the cooler our temperatures get. So all of this direct solar radiation is going to affect the rainfall patterns. We already saw that it affects temperature, but it also affects our rainfall. So when that direct sunlight hits the equator, it warms everything up. And when water vapor warms up, so when water warms up, the water vapor rises. So you can understand what this is happening by thinking about boiling a pot of water on the stove. So when you heat water to boiling, that steam that comes up, those are hot water molecules, and that steam rises. The same thing happens at the equator. So that direct sunlight is going to hit our equatorial region, and it's going to warm the region. It's going to warm all of the water in that region. So now we have two things going on. One, the water in the region is rising. The other thing is that warm air holds more moisture. So we start to get really humid regions, and also regions that have a lot of water that is rising and accumulating in clouds. So these red lines here, that is showing the humidity or the water vapor rising. And as that water vapor rises, the air gets cooler the higher we go. So the higher we go, the cooler the air. So higher equals cooler air. So we've got a little bit of physics happening here. As that sunlight heats up the water, we're going to excite those water molecules and they're going to begin to evaporate off. The warm air at the surface is going to hold the air, which is going to make it hot and humid. But as that warm air continues to rise, because warm air rises, as that warm air continues to rise, it's actually going to cool. So when you get really high up into the atmosphere, it starts to get really, really cold. And when we get high up into the atmosphere, that cool air is going to cause the water vapor to condense. And so what happens is that warm, humid air condenses into clouds. And what happens when those clouds get too heavy? It rains. And so we get rain falling back down into the equatorial regions. So we get lots of rain along the equator. So the rain falls back down, but the air doesn't fall back down. The air actually moves out away from the equatorial regions on either side. And that rain then the air, which has now lost all of its moisture, begins to fall and it begins to cool. And so we get these regions away from the equator that are warmer because that warm air has fallen, and also drier because the equatorial region air masses have already dropped their moisture back onto the equator. And so around 30 degrees north and south, we start to find these subtropical dry regions. So they are going to have drier winters, maybe some wet summers, maybe very, very dry summers. But around that 30 degrees north or south, we're going to see these warm, drier regions. And then these cells of air are going to do the exact same thing. That dry air from these subtropical regions, that warm air is going to rise. And if there's any moisture, it's going to take it with it. And so we're going to get a little bit of rain here. But that warm air is going to rise and cool. Any vapor, water vapor in the clouds, in the air is going to condense into clouds. So we might get some precipitation away from the subtropical dry areas. So this pattern is going to repeat over and over again. So I'm going to very quickly go through it one more time because this can be kind of confusing. So at the equator, that warm air is going to pick up moisture and it's going to rise. So that warm air is going to rise. There's a lot of water vapor in that air. As that warm air rises and cools, that water is going to fall back down as rain directly back to the equator. Then that cool air is going to fall again, come back down. What that's going to do is send a cycle that causes sort of a circular pattern. So that air is going to fall back down, warm back up, rise, drop its water, fall back down. Then away from the equator, between 30 and 60 degrees latitude, we've got the same thing happening, except that our air is not as moist. These are drier regions, so there's less moisture to pick up, but any moisture that is in that region could get picked up, pulled by warmer air, condense into clouds, it cools off, and then begins to fall again. Condensation from the clouds could fall back as rain. So that's why we tend to have less rain in the higher latitudes, although there are definitely some regions that get some rain. Then farther north, we have the exact same thing happening. We get air rising and falling, except that the air is much colder and there's much less precipitation there. So we tend to not have much precipitation in any season at our poles. If you need another explanation of this, there are some videos posted in Brightspace under the additional resources tab for chapter 45. So we also have seasons that affect the overall weather pattern. So the changes in the air circulation and the rising and falling of our moist air is going to affect the really big patterns in an area. And it is going to affect the type of precipitation that we see in different seasons. But this is also compounded by the fact that the earth is tilted. And so because the earth is tilted, each half of the earth is going to have a different time of the year where it gets the most direct sunlight. So no matter what, the equatorial regions are always getting intense sunlight, and we can see that. No matter which angle the earth is tilted at, we can see that there is more direct sunlight at the equator than either of the poles. But because the earth is tilted a little bit on its axis, there are times of the year where one or the other hemisphere is turned or tilted more towards the sun, and so it receives more direct sunlight. So in the winter, the sunlight, so if we look at us, so we're on the northern hemisphere. We are on the northern hemisphere, and in the winter, we are getting less direct sunlight because the direct sunlight is hitting the southern hemisphere. The northern hemisphere in the summertime, we are getting, that's us here, we are getting more direct sunlight in the summer. So the sunlight is hitting the northern hemisphere at a more direct angle. So this is going to cause warmer temperatures for our summer, cooler temperatures for the southern hemisphere winter at the same time. In the winter, the northern hemisphere has cooler temperatures, while the southern hemisphere has warmer temperatures because they are the ones getting the direct sunlight. And so what we get is seasonal variation away from the equator. The farther you get from the equator, the greater the seasonal variation. Around the equator, there's really not a change in seasons. There might be wetter and drier seasons, but as far as cold and warm seasons, we don't really see that along the equator because they're getting direct sunlight the whole year round.